Alright, in this video, I'm going to show you how to perform row operations on the matrix. And remember, there are three basic row operators that we can use. The first one being what we call the row switch. And if you look at this first problem, problem 17, the first thing I did was I created the augmented matrix. So again, remember the augmented matrix is where we take the coefficient matrix and we attach it to the constant matrix. And in this particular problem, I'm going to use the row switch operator. Row switch just means you take, in this case it says, take row 1 and switch with row 3. And remember, we want to do row switches in the matrix because we want to get that diagonal to have ones on it and zeros everywhere else. So if we see a row that has a one leading 1, we always want to row switch that to be the first row in the matrix. But in this case, I'm going to go row 1, switch with row 3. And remember, we write it like this, the double arrowhead. And I would do this now. So we get row 1 moves to 1, negative 1, 1, negative 1. Row 2 we did not touch, so leave it the same. And then we move row 1 to become row 3, so we get 1, negative 2, 2. So the first option we have, we perform these matrices, and we try to solve these matrices is to use what's called the row switch. Now, the next option we have available to us is we can either add or subtract rows, depending on what we want to get done. So in this case, I'm going to subtract row 3 from row 1. And it looks like this. And I'm going to replace that with row 3. So again, we're not going to touch the first two rows. So 1, negative 2, 2, negative 1, 2, negative 3, negative 2, 3. But this time, I'm going to take row 1, which is here, and add it to, or subtract this row from it to get the new row, row 3. So this says row 1 minus row 3 becomes row 3. So here we go. We're going to take 1 and subtract off row 3. So 1 minus 1 is a 0. We're going to take negative 2 and subtract off negative 1. We get a negative 3. We're going to take 2 and subtract 1. We get negative 1. Then we're going to take this negative 1 and subtract off a negative 1. So that's negative 1 minus a minus 1. So negative 1 plus 1 gives me a 0. So here is the new matrix created by subtracting row 3 from row 1 and getting the new row 3. And the last operator we're going to use is the scalar multiplication operator, which allows us to multiply any row by a scalar number. And then we can perform the addition or we can actually multiplication, same thing as division, so we can actually divide rows if we need to using multiplication. So here it says to multiply negative 2R1 and then add that to R2, and that becomes a new R2. So that means we're going to go here on the second row, negative 2R1 plus R2. It's going to produce this matrix here. So first row, don't touch it. 1, negative 2, 2, negative 1. The second row, we're going to take the first row, multiply everything in that first row by negative 2. And if you need to remember, write the numbers up here to help yourself out. So negative 2 times 1 is negative 2. I'm going to add R2 to that. So I'm going to do negative 2 plus 2. That's going to give me a 0. Then I'm going to multiply negative 2 times negative 2. That's a positive 4. I'm going to take 4 plus a negative 3 and get 1. Then I'm going to take negative 2 and multiply it by positive 2. I get a negative 4. I'm going to do negative 4 plus negative 2. That is going to be a negative 6. And then negative 2, again, negative 2 times this negative 1 is a positive 2. I'm going to do 2 plus 3 and get 5. And in that bottom row, we don't touch it. And so here is the new matrix that we created by performing that transformation. Now, in these next set of problems, I'm going to give you the steps that are going to get you all the way down to the reduced matrix. And from that reduced matrix, you should be able to see the actual solutions from it. So when we do this, let's follow each one of these steps. The first thing we're going to do is write the augmented matrix. And the augment looks like this. This is a 2 by 2 augment. So we're going to do 3, 4, and 1. And the second row will be 1, -2, and 7. So what we need to do again is we need to get 1s on the diagonals and 0s everywhere else. And so we can already see while we're doing this first part in A, which says switch R1 and R2. So we're going to do a row switch first. When we do that row switch, let's make this first row be red and second row be blue so you know what I'm talking about. I'm going through this. We're going to move the blue row to become the red row. So we'll make this be 1, -2, 7. And the red row will be 3, 4, and 1. So first step was perform a row switch, R1 to R2. Now, the next thing says to multiply -3R1 plus R2. And that's going to be the new R2. Well, why are we doing that? Remember, we have 1s on the diagonals, and we need 0s to be everywhere else. So right now I can see that I need to get a 0 right here in the E21 spot. So in order to do that, I'm going to multiply 3R1, -3R1, and then I'm going to add that to R2. So here's what happens now. When we do that, we get -3 times 1 is a +3. Or first, actually, we don't touch the first row. The first row will be 1, -2, 7. The other row will be, we're going to multiply -3 times 1, which is -3, plus 3 is 0. -3 times a -2 is a +6. A +6 plus 4 is 10. -3 times 7, so -21 plus 1 is a -20. The next row, the next thing we're going to do says to multiply 1/10 of R2. That becomes the new R2. Well, why are we doing that again? Again, remember, 1s on the diagonals, 0s everywhere else. I can see that these have a constant multiple of 10 in them. So they should be divisible by 10. And again, we're multiplying by 1/10, which is the same thing as dividing by 10. Because our rules say that we can multiply. So now we're going to do this. First row stays the same. 1, -2, 7. But the second row, we're going to multiply everything by a 1/10. Because that's going to give us a 1 in this position right here. And so 0 times 1/10, 0. 10 times 1/10, 1. And -20 times 1/10, the -2. So look what we've done. We've gotten this to where we can see that we know that the x2 variable is equal to -2. And if we wanted to, from the other notes, we know we can go back and back substitute to find x1. We're going to keep going, though, and get this to 1s and 0s, which means that I need a 0 up here. In order to do that, how do I do that? I'm going to multiply the second row by 2, because this will make this 2. I'm going to add it to the top row. So second row is not going to change in this. So I get 0, 1, -2. And now what I'm going to do is I'm going to multiply 2 times this row and add it to the top row. So 2 times 0 is 0, plus this 1 right here is going to be a 1. 2 times 1 is 2, plus the 2, plus the -2 is going to make this a 0. And then 2 times -2 is a -4, plus 7 is going to give me a +3. And so now by doing all of this, I can see that my solutions are going to be 3 and -2. And we can go back and check these solutions. If you plug those back into the original matrix, they should give you the actual answer. And I'll show you real quick. 3 times 3 is 9, plus 4 times negative 2 is negative 8, so 9 minus 8 is 1. And then 3 times negative 2 times a negative 2 is a positive 4, so that's 3 plus 4, which is 7. So those are your solutions.